Pandas is the basic package for data analysis in Python. It provides integrated data manipulation and analysis. So the key here is that you can manipulate data and some basic analytical capabilities, and the power really comes from the fact that it feeds into various machine learning libraries that you can then take the basic Panda data structures and feed them into all kinds of different packages that you can use for more powerful analysis. It's well integrated with data visualization libraries. Pandas comes by default. You can use any matplotlib function in it. So you get the matplotlib libraries are already inbuilt into it. So for very quick visualization of graphs, etc., Pandas is really good. If you want to do more complicated stuff, then you can use one of the other libraries we mentioned, but for the basic stuff, it's really, really good. It also has built-in time series capabilities, which is very useful. We'll see that there. It's optimized for speed. It's got NumPy sitting underneath it, so that's always a good thing. And Pandas is open source, so it comes with a bunch of libraries that are useful for getting data. You can get data from CSV files, from Excel files, from HTML pages, grab all the tables, Google, from the World Bank, from the Federal Reserve. We could, till recently, get data from Yahoo, but it's an open source library. So Yahoo made a change to their underlying data structures in HTML pages, and so currently this is not working. But that's the the pitfalls of working in the open source world. But it will hopefully it'll get fixed, and someone will make it work sooner rather than later. There are workarounds around it. You can Google them, but we will not focus on that right now. The main things in Panda is that it organizes data into two data objects, and that's the data structures that it works with. The essential idea is something called a data frame, which is a two-dimensional table object in which it can recognize the columns and can recognize the rows, and you can address columns and rows by name rather than having to go through like 0, 1, 2 as we do in lists and arrays and NumPy arrays and all that. And each so that's a two-dimensional thing, and each column or each row is also a series of one-dimensional array object, which again has meta information built into it that's kind of useful. So this is the key thing with Panda that we are interested in, is how to work with series and data frames, because that's when we go to machine learning and all that kind of stuff, we're going to be using Pandas data frames as our basic data structure. Each column corresponds to a named data series, so a column has a meaning, and you can index every row, right? So every row also has a meaning. So you can think of in time series, for example, you might have open, high, low, close, etc. prices, and then you have a date stamp. So the date stamp is a row index, and open, high, low, close becomes a column name, and that becomes your data frame that you can then use for analysis. So that's how Pandas works. So let's take a look at Pandas in practice, and we go to our Pandas notebook over here. So before we do anything else, let's make sure we have everything installed. So the first thing we have to work with is that we need to make sure that we have these two libraries. Pandas comes installed in Anaconda's Python by default, so we don't have to worry about Pandas. However, for reading data, there's a nice library called Pandas Data Reader that we need to download. And Pandas Data Reader for the HTML part uses HTML5lib, but it uses this particular version of HTML5lib. So the first thing you want to do is you want to download these two things and make sure that your HTML5lib that you're working with is 1.0b8. Okay, so let's run these two. And so we have both these installed. And just to be on the safe side, after you install stuff, it's not a bad idea to restart the kernel. So if you restart the kernel, and here what I'll do is I'll clear all the output as well, so that we don't have anything. If you restart the kernel, then you are sure that any changes, because when you install one library, it might be loading other modules and installing those as well, or updating them or changing them. And what you want to make sure is that you are not in your current notebook, which is not going to be the case in our case right now, but because we are starting with this. But if you install it later, for example, then you want to make sure that the current notebook has the latest library loaded inside it. If it already loaded the library previously, it's not going to reload the new version just because you've got a new version in there. So that's the goal there, right? So once we got this stuff here, we want to work with the imports. I've put all the imports up front here, but of course we can do them anywhere we feel like before we use them, but just to make sure we have all of them. So we of course need pandas, so that's our base library. We need pandas data reader. Okay, this is for reading data from Google, getting HTML from tables, that kind of stuff. We want to import numpy as NP. Right? And pandas typically is loaded with the alias PD. Again, this is just a convention. It's not a requirement. We're going to import matplotlib.pyplot and call that PLT. Just that's our alias for that. And we're going to import datetime and as DT. Well, we don't have to. We can conventionally. We don't really need to do that, but try to do that. What we'll do is we'll get rid of this because typically you don't need that, right? So I know I have that there. And the only other thing that we want to make sure is we use this command here called matplotlib inline. The % is a Jupyter command. It's telling the browser something that is a meta function on the browser itself, right? So Jupyter has a whole bunch of things you can do on the page. We have not really looked at that at all. We are focusing only on Python, but there's a lot of stuff you can do with that as well. So one of the things we want to do is we want to tell it that any graphs that we draw using matplotlib, and remember matplotlib is part of pandas, so it's, pandas can automatically access some matplotlib functions, but any graph that we want to draw using matplotlib should show up on our browser itself. If you don't do this, then it's going to pop up a window somewhere behind and you won't know that it's there, and your browser will be waiting for you to complete that. It's a kind of a mess. So when you're working on Anaconda, it's a good idea to add this, but not if you're writing your code somewhere else, like in an IDE, like perhaps PyCharm or something like that, then you don't need it. But if you're, or Eclipse, but if you're working in the Anaconda Jupyter notebook, then in the Jupyter notebook you should always do this because you want the graphs to show up right there in the output part of your thing. So these are the imports that we want. So let's run this, and we got them all imported. And let's start by looking at a data frame. So here, the data frame, like I said earlier, is a bunch of columns and a bunch of rows. And what we want to do is we want to give our columns names. So what we are saying is take this data, which is these two rows here, 1, 2, 3, and 1, 2, 3, and give, so there are 2 rows and 3 columns. And for each column, we're going to give the name, we're going to give a name to each column. So column 0 has the name A, column 1 has the name B, column 2 has the name C. And we can look at this and we get a data frame that looks like this. So here, what do we see? We see that pandas has given column names, right? And it's given row indices. So since we didn't specify an index explicitly, it's made up an index of row numbers, 0, 1, etc., right? And that becomes our index over there. But this is the basic structure of a pandas data frame. The idea is that the data is sitting in here, in this 1, 2, 3, 1, 2, 3 stuff, and we've got a bunch of row indices and a bunch of column indices that we can then use to access data, just like an Excel spreadsheet. In an Excel spreadsheet, you have A, B, C in the columns and 0, 1, 2, 3 in the rows. So you can think of pandas as a slightly more knowledgeable version of Excel, okay, and at least in the terms of data structure.